that on? Hello? Is that on? Just kidding. I gotta come up with an original start to every video. I mean, otherwise it's kind of boring. Here we are. We're getting ready to do January 2014. I'm doing 15 through, what is that, 27 in this video. You ready? Let's get rock and rolling. I think we're on page 7. Nope. Page 6. Yep, there it is. Nope. View. Page. Oh, man, I'm on the wrong page. Page width. I got one problem left on this page. Alright, there's my work from the last stuff. Alright, let's get going. Let's get rocking. Let's get going. I can't use that. That's kind of boring. Alright, I'm still drinking the same cup of coffee I was doing on the last video, so I need to get going. Alright, so clearly this is a circle. And if you remember formula for circle, it's h, that's x, what is it, minus h squared plus y minus k squared equals the radius squared, where h and k are the center. Remember, they go in with opposite signs. So they also come out with opposite signs. So that's the first thing we're going to do. Now we're going to do this thing by completing the square. We're going to put the x's together. X squared minus 16x plus a box plus y squared plus 6y plus a box. That's why I call it completing the square. That's why I call it completing the square. Now, that's not really why it's completing the square. The negative 53 goes over here. Don't even really care about that, because the only thing it really wants to know is the center. Now, if you remember the rules for completing the square, it's half of this term squared. Goes here, 64. Half of 16 is 8. 8 squared is 64. So if I was actually doing this problem, I'd have to add 64 over here in another box. Oh yeah, I have 2 boxes over here. Half of this squared goes here. That would be 9. I'd have to also add 9 here. Don't really care if I do that or not, because it's not asking about the radius. If it was asking about the radius, I'd have to add all that up. All I care about is what's going in this set of parentheses and what's going in this set of parentheses. Well, whatever half is, in this case it's negative 8, that's what goes down here, x minus 8. And whatever half of this is, that's what goes here, y plus 3. So there's your center, 3 and negative 8, but when you pull them out, remember they come out with opposite signs, so it's 8, negative 3. Choice 3. And now we move on to page 6. I wish we would just automatically default to that. All right. Tough problem. Tough problem. Only the domain is really the tough problem in this one. So there's 2 types of problems originally that we have issues with for domain. That is if we have a fraction. If I just had this, 3 over x minus 4, then my domain would be, hey, x could be everything except x can't be 4. Because if I had 4, that would make the denominator equal to 0. So x is not allowed to equal 4. So anywhere it says equal 4, we got to get rid of. Anywhere it says x can equal 4, we got to get rid of. Okay. The next thing I got to worry about is radicals. In order for this to be a real calculation, not imaginary, this has to be a positive calculation right here. When I add these up or subtract these up, I have to have a positive calculation, which means that if x was 3 or 2 or 1 or 0, that would cause us problems. So in this case, x would have to be greater than 4. Not equal to 4, but greater than 4. And that's both of these. All right. Now, oh, that's the first part. Now we gotta worry about range. Now, if you notice, the only difference in range is this one says I can be just greater than 0, and this one says I can equal 0. So the question is, can this fraction ever equal 0? Well, the only time a fraction can ever equal 0 is if the numerator equals 0, and there's nothing you can do to that numerator to to change it. It will always be 3. It can never be 0. So the answer is choice 1, y, right here, because y can never equal 0. Sorry, my eyes are bothering me right now. Math Club has 30 boys and 20 girls. Which expression represents the total number of 5-member teams consisting of 3 boys and, we'll just get rid of all this adding and subtracting, and, because and means multiplying when we're talking about probability, and 2 girls. So, if you have 30 boys and you pick out 3 of them, doesn't matter what order you pick in. Is if they're going in the group, does it matter if I go, Bob, Joe, and James, or James, Bob, and Billy Bob, and James and Joe, or Joe, Billy Bob, and James? It doesn't matter what order I picked them in. And if order doesn't matter, and order doesn't matter on teams, committees, or groups, if order doesn't matter, and if you're picking a team or picking a committee or picking a group, it doesn't matter. That's always combinations. Combinations doesn't matter about order. 30, choose 3 boys. 20, choose 2 girls. And because it said and you're pulling that committee together, you got to multiply them, not add them together. All right, kids, product and sum of the roots. Let me just review both of them with you, because I know that's what you're like. I wish Mr. Krause would just do more math, not just the regular math. I wish he would do more math. I know that's what you're thinking. So while I've got your undivided attention and I can't find my pen, every time I try to find my pen, I always write on something. All right, so sum of the roots is negative b over a. And the product of the roots is c over a. This is A, this is B, and this is C. So, in this case, the product of the roots is K over 1. Or, in this case, just K. Great. What's K? I don't know, but I bet you can find it. So just in case you're wondering, the product of the sum of the roots is, take the negation of this, which would be positive 4 over 1, which would be 4. Is that one of the answers? Nope, not even one of the answers. So, don't need that. All right, so let's see. I've got another part of this problem. It says the one of the roots is 7. Now, if you remember correctly, a root is what makes the equation equal to 0, crosses the x-axis. So when I plug it in for x, I should be able to get 0 out. So when I plug 7 in, I get 7 squared minus 4 times 7 plus k equals 0. Well, that's 49 minus 28 plus k equals 0. Or 21 plus k equals 0. Now, when I bring the 21 over, I find out, oh, k is negative 21. Well, if I go back and put it back in my formula, my answer is negative 21. And that's it, kids. That's all she wrote. Party's over. How many distinct triangles? Law of signs. Law of signs. I'm actually writing signs. S-I-N-E-S. That's freaking embarrassing. I'm going to blame my students for that. They made me dumber this year. Well, only a couple of them, BP. You know who I'm talking about, BP. Just kidding, BP. You're one of my favorites. All right. I don't know why I picked A, B, and C. I guess I just assumed, and assuming makes an ass out of both you and me. And I put 2 B's, not even a C. That's embarrassing. Thanks, BP. D, E, F. I need a little more room, and probably my big head's getting in the way. Let's see. Angle D is 32. Google Drive. I had to get the formula sheet up. It's because I wanted to remind you about it. All right. Little d is 5. Little d, remember, is opposite big D. little e is opposite here. So that goes here. So here's what we're going to be looking for. We're going to be looking for E, measure of angle E. So if you remember correctly, the law of sines is side over sine of an angle over side of a sine of an angle, and you got to set two fractions equal to each other. So we're going to be doing 5 over the sine of the angle opposite it, which is 32, equals 8 over sine of E. So I'll cross multiply and I'll get 5 times the sine of E equals 8 times the sine of 32. Then I'm going to divide by 5. And some weird stuff happens. I love seeing kids' reactions when this happens. You'll see. You'll know what I'm talking about. Let me make sure my calculator's in the correct mode. It's in degree mode. That's great. Control. Oh, there's so much garbage on my screen. I hate it. Let's get rid of it. Control division. And that was 8 sine 32 divided by 5, right? And this is what I get. What? Huh? That's not the right answer. I don't understand. Mr. Krause, that's not the right answer. Yeah, you're right. It's not. I don't remember what that was. Was it 0.8 something? 0.84787. So 84787. You're right. It's not. Because I have to take the inverse of this. Remember, I'm looking for an angle, so you have to take the inverse sine of this thing. Remember, that's the last step a lot of times in the law of sines. So we're going to do inverse sine of that thing. And we get 57.98 degrees. So I come over here and I say, okay, triangle 1. Triangle 1 would be 32. And what was that? 59 point what? 57.9. So let's just say 58. 58. Well, that would give me 80 plus 10. That would give me 90 degrees. Ooh, those two would add up to 90 degrees. That means my third angle would be probably around approximately 90 degrees. Now, so triangle 1 works. I can definitely have one triangle, so I'm not going to have 0. You can never have 3, so it's either 1 or 2. Can I get another triangle? So let's check for triangle 2. That would be 32. Now, sine is equal to this in the first quadrant, which is the reference angle, about 58 degrees. But I also could take 180 and subtract that to get the other angle, and that would be 122. So my other angle could be 122. Well, that's 154. That leaves plenty enough for a third angle. Therefore, there are two triangles. Not 1, but 2. And not 3. Never can be 3. Could be 0, 1, or 2. Let's apply for college. It requires a student to score in the top 6.7% of the math portion of the aptitude test. The scores are on there approximately normally distributed with a mean score of 576. Let's get that X bar. 576. And the standard deviation of 104. What is the minimum score she needs to do in order to be in the top 6.7%? So, if you look at your normal distribution curve, top 6.7% is over here. So, this is my X bar. This is 576. Now I'm going to go to my sheet, and I need to find 6.7%. Let's see. 0.1 and 0.5 is 0.6. 0.6 and 1.7 is 2.3. 2.3 and 4.4 is 6.7. So what I'm looking for is, I wish I could annotate, I need to come up with 1.5 standard deviations above the mean. I'm looking for, I know there's some annotation tools. Is that it? Nope. That it? Nope. Well, whatever. So these, when I add these up, 4.4, 1.7, 0.5, and 1.1, I get 6.7. So I want to be in this tail where there's 6.7%. Well, that means I'm going to get this thing right here. I want to be on this 1.5 standard deviations. So I'll take this and I add 1 standard deviation. 1 standard deviation is 104. So if I take that and I add 104, that gets me at 0.8680. That puts me at 1 standard deviation, which is 680. I need to go another half. I need another go to half. So half of this would be 52. So I need to go up 52 more. So I'm going to take that 680 and I'm going to add on 52. 2, 3, 732. There it is. Because that gives me to that magical 1.5 standard deviation. Now the easiest way to do it would just take 576 and add 104 plus 1.5 or times 1.5 standard deviations. And if you did that right away on your calculator, 576 plus the standard deviation of 104, and you need one and a half of them. You just add 1.5 and you get your 732 right away. All right, that's the easiest way. We're getting there, kids. My kiddies are going to get good grades on the Regents exam because they're working their butts off. All right. What is the square root of x squared? Oh, x, you say? What's the square root of x to the 4th? Oh, x squared, you say? What is the square root of x to the 5th? That's a 5, by the way. Isn't that really just the square root of x to the 4th times x? And isn't x to the 4th really just x squared times x? Well, yes, it is. But, Mr. Krause, we don't have square roots. We have cube roots. Well, the same rules apply for cube roots. If I have the cube root of x cubed, that's x. If I have the cube root of x to the 6th, that's x squared, because that's 2 groups of 3. If I have the cube root of x to the 9th, that's 3 groups of 3. That will be x cubed. If I have x cubed, this cube root of x to the 11th, crap, not as easy. So what you want to do is rewrite it as groups of 3. Well, that's x to the 9, because 9 is a multiple of 3, times x squared. And then I say, oh yeah, x to the 9th is x cubed when I take the cube root of it, but all that other crap's got to stay under the radical. So that's what we're doing. The other thing we're going to do is figure out what our perfect cubes are. Our perfect cubes. So let's look at this then. They actually decided to make this one a little bit nastier than normal. 27x squared times the cube root of 16x to the 4th. I'm going to tackle this slightly different than I normally would because this is nasty. 27 is a perfect cube. The cube root of that is 3, so that gives me 3. But this 16, not the funnest thing in the world. So what I'm going to do is I'm going to rewrite that right now as a perfect cube and not a perfect cube. And so the perfect cube that goes into 16 is 8. 8 times 2. Your perfect cubes are, the first one is 1, but that's useless. 8, 27, 64, and 125. Now, do you have to go any more than that? Probably not. The next one will be 216. And then, I don't know what 7 cubed is. It's like 729 or some ridiculous thing like that. So, the cube root of this, 8, is 2. So, it's definitely going to be 3 and 2 with a 2 inside. So, that's 6 with a 2 inside. It's one of these two. Now I'm going to deal with the radicals x's, the cube roots of x. So this is the cube root of x squared times, excuse me, the cube root of 2, the 2 stays under, x to the 4th. Well, that gives me the cube root of 2x to the 6th. Ah, that's not bad. The cube root of x to the 6th is x squared. So that comes out. So the only thing under the radical is the square root of 2. There's your answer right there. We're done. Which graph shows the inverse of a to the x where a is bigger than 1. Let me make sure I haven't given you any wrong answers. Well, if a is bigger than 1, like a 2 or a 3, that's an exponential growth question. That's one of these. And if you don't believe me, come over to your calculator, go into the graph mode. If anybody else's garbage is in there, you see all this stuff here? We don't want to get rid of that because that means we probably are in bad mode. So no. And we'll go back in and we'll go graphs. And I want to graph, I don't know, 3 raised to the x power, because that's what they're asking. Look, there it is. So, and if you remember correctly, inverses are reflections over the line y equals x. So I'm going to graph the line y equals x here and put that in. There's the line y equals x. Well, where would the inverse be? It would be the reflection over that. So when I go back in my test and I look, which one is the reflection over this line? This is the reflection over that line. This is the function. And these two aren't right. So choice 3. Moving on. All right, so you're dividing by 2 minus x over 1. When you divide by a fraction, you whoop, flip, and multiply. So I'm going to do that. I'm going to flip that thing, 1 over 2 minus x. And anytime I see a 2 minus x, whoop, 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 in your mind, you got to think, this is going to be a negative 1 rule. Got to remember, it's going to be a negative 1 rule. So let's see what we got here. The denominator here is x minus 11, x plus 11. That factoring is pretty easy. And the numerator is pretty easy. It's x plus 11 and x minus 2. All right, so now I start lopping crap off. I don't think they were very nice to us in this problem. This x plus 11 is going to cancel with this x plus 11. Now, this is, in fact, going to cancel with this, but it makes the negative 1 rule. So just stick a negative 1 somewhere up in the numerator. So my answer is negative 1 over x minus 11. And I haven't looked at the answers yet, but I'm thinking they weren't very nice to us. So clearly it's not this one, and clearly it's not this one. It kind of looks like this one, but I have negative 1, and I don't have a negative 1 here. So what these nice people did was they decided to take this negative and distribute it in the denominator. Negative x plus 11. And that's why this is the answer. So they weren't being very nice to you. That's the answer. Now, having said that, this is another one that you could check your answer with using the calculator. Go over to the calculator mode, get rid of all the garbage, and just pick any number. I'll take 5. I'll stow it into x. And I'm going to look over here. It's control division. X squared plus 9x. X squared plus 9x minus 22 all over x squared minus 121 divided by parentheses 2 minus x. So if you type that in right, by the way, you can't use 2. You also couldn't use 11, because if you did, you'd end up with something that's undefined. So you make sure you don't use something. If you end up with something that's undefined, just pick a different number for x. This is a great test-taking strategy, so know for sure that you got the right answer. Bam, 1/6. Okay, maybe. I don't know. That looks funky. Let's see if my answer gives me 1/6. So 1, control division, 1 over 11 minus x. That was what I chose as my answer, 1/6. Another quick way to check to see if you got it right. I'd like to know for sure if I got it right. All right, so what we got here? We got something that's screwing up again. All right, I think we're back. Page width. Okay, which graph represents the solution of this? Whoa, 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 whoa. Let's back up there, sister. Well, clearly x can't be 2, because that would make that undefined. So 2 should be something where I have an open circle at 2. Open circle at 2. Open circle at 2. This includes 2. That can't be it. And I don't know about that one. We want negatives. We want this to be less than 7. All right, so what I'm going to do is I'm going to multiply both sides by x minus 2. So I get x plus 16 if I multiply both sides by x minus 2. Let's see if that works. Is that going to help me out? I think so. I don't know. This thing's bothering me. I'm just going to plug in numbers. Let's just plug in numbers. I don't really like this problem very much. It's a good problem, I guess, but I don't really like it very much. I know it's not this answer. I know it's not this, because this includes 2, and it can include 2. This one doesn't include 2. But for some reason, they all include 5. I'm not really sure why, but I'm assuming 5 works. So if 5 works, then I got to check a number bigger than 5. So I'll check 10. So if 10 works, then I can get rid of 4. So let's try 10. 10 plus 16 is 26, divided by 10 minus 2, which is 8. 26 divided by 8 is approximately 3 point something. Is that less than 7? Absolutely. So the only thing now that I have to check is a number that's less. I got to check numbers down here, because if numbers down here don't work, then I know it's choice 1. So they give me an easy one to check. I'm just going to check 0. I'll plug 0 in. I get 16 over negative 2. Well, that's negative 8. Is that less than 7? It sure is. So 0 works. So if 0 works, it's got to be part of the solution. So choice 3 is your answer, kids. Moving on. That was kind of obnoxious. I don't like that question. View, page width. All right. If you remember correctly, period is equal to 2 pi over b. So we're dividing by b. And if you also remember correctly, the number in front of the x is the b. Well, if I divide by 2, that would give me pi. Not right. If I divide by 4, that gives me pi over 2. Put a 4 in there. If I put a 2 pi over 4, that certainly isn't going to give me 4, so that's not it. So it's got to be one of these fraction ones. So let's try 2 pi over 1/2. When you divide by a fraction, what you're really doing is you're multiplying by the reciprocal, 2 over 1. So this gives me 4 pi, and there's my answer. And the other thing you could think of is it says, oh, it's going to take me half. I'll finish. What this says is I'm going to finish half of a curve. Remember, this is the frequency. I'm going to finish half of a curve in 2 pi. Well, if it takes me 2 pi to finish half of a curve, it would take me 4 pi to finish a full curve. And a full curve is called the period. All right. This expression is equivalent to, so we're going to distribute. So I get x cubed plus 2x squared. And then distribute. Why is this problem? Minus x. Oh, crap. That's not what they're doing here. Sorry, didn't see what they're doing here. I mean, I could have finished this, and it's kind of stupid. Minus x minus 2, but that's not one of the answers. Well, that's close to one of the answers. It's close to this one. You know, you might want to think it's this one, but it's not because it's minus 2. So if a kid forgets to distribute that negative, they won't do that one right. So, so here's what they're looking at. So that's not what they really want. What they really want you to do is look to factor this thing. Notice they have a common factor of x plus 2. So x plus 2 should be in there. Now, if I take away the x plus 2 from both of these things, what am I left with? Well, I'm left with x squared minus 1. X squared minus 1. Well, isn't x squared minus 1 the difference of perfect squares? Can't I take this thing, and doesn't this give me x plus 1, x minus 1? And then don't forget we still have the x plus 2. And so there's my answer. Now this is another perfect example of where you can use your calculator to just do the whole daggone thing for you. If I remember correctly, we still have 5 in for x, right? Yep. So let me get rid of all my garbage. And let me look over here. It was x squared, parenthesis, x plus 2. Believe it or not, lots and lots and lots of this test can just be done using your calculator. X minus 2. I put that in, I get 172. I have no idea. And then I'm going to put my answer in. My answer in was x plus 1, x minus 1. Oops. Careful. See, I got my parentheses messed up. You want to be careful with that. You got to get out of these parentheses, then do another parentheses, x minus 1, get out of those parentheses, and then parentheses x plus 2. Make sure you look at it. Does that look like your answer? Oh. So classic mistake. I'm like, what the heck's going on here? Classic mistake. Look back at my original here. What I typed in was my original problem. Is that really what my original problem was? Common mistake made when trying to cheat is being stupid like I was. I'm pretty sure this was a plus in the original problem. And it was 168. And now notice they match, right? So there's another way to do it. And finally, number 27. How many degrees are there in 5 radians? All right, so let's talk about radians real quick. Would you all agree pi is equal to 3.14 radians? Pi is also equal to 180 degrees. So 3.14 radians is really 180 degrees. So this is pi, or 3.14 radians, or 180 degrees. So if I'm going 5, well, if that's pi, this would be 2 pi, or 6.28, is double 3.14, or 360 degrees. So if I'm going 5 radians, I am going past 180, and I'm going to be somewhere in this area right here. Somewhere in this area. Somewhere in the mid 200s. So I'm guessing that the answer is going to be 1. Now that's the thinking your way through the problem. You can also, and I hope you remember this, to convert from degrees to radians, you take the radians and you multiply by 180 over pi. Now if you didn't remember that, your only two choices are to multiply by 180 over pi or pi over 180. Let's see what we get for our two answers. Let's do it the right way first, which is this. And you'll take 5 times, and do fraction, 180 over pi, and hit enter, and there's your 286.4. That's why it's 286. The only other answer that you might come up with, because you got your thinking backwards, we do pi over 180, you're going to come up with some ridiculous answer of 0.087 degrees. Is that even one of the answers? No. So the answer is 286. All right, kids, that's it. A couple ways to do problems. Hope you learned something. Hoping I taught you something. I hope you had fun. Probably not. Summer's coming. It's about time. Get ready. Hope you guys have fun at the proms, too. Be safe. Don't do anything stupid. Behave yourself. Behave yourself. And if you get into trouble, call your parents. They're going to be mad and love you at the same time. All right, kids, have fun storming the castle. Love you all. Bye.